In number 9, there was an error in some of what I've given you, but I don't think it caused anyone too much duress here because I didn't notice us missing it. This hole should not have been at 5, 0. The hole was actually at 5, and 24 fifths. It's just that I gave you the y coordinate incorrectly, but as far as us building the equation, it didn't do a whole lot to impact our equation. It maybe when we graphed it could have caused a little confusion there, so apologize for that, but I don't think it threw anybody off anyway. So here's what I want to mark on my picture. I want to mark the x-intercepts where our graph crosses the x-axis. It crosses it at 2, and it crosses it at -3. The next thing I want to do is I want to mark the vertical asymptotes at 4. So there's a vertical asymptote at 4, and we also have one at a -5, so that's in between here. There's a hole or a point discontinuity at 5, so when I come over here to 5, I've got to pay really close attention that I don't forget at 5 I have to have a hole in my graph. And then finally there's a horizontal asymptote at y equals 2. So when y equals a 2, that's going to be fairly low when we think about the tick marks on this graph, but it is not at 0. So there's some of the key features of my graph, and now I'm going to build this rational equation. So the context clues that we have, things that we use to build the numerator are your x-intercepts. We had x-intercepts at a -3, so that's a factor of x plus 3. And at 2, that's a factor of x minus 2. It also told us that we had a hole, and I'm going to pick up that hole right away. That hole happened at 5, so that means at x minus 5. And we also have to have an identical factor of x minus 5 in the denominator in order to create holes. The other things that we use are our vertical asymptotes, of which we had 2. There's a vertical asymptote at 4, which meant your factor is x minus 4. And also at a -5, so that means your factor is at an x plus 5. So right now I've got all the things in place. I've got the holes, vertical asymptotes, x-intercepts. What I need to reckon with now is the horizontal asymptote. Since the horizontal asymptote is up here at 2, what I want to do is I want to make sure that I look at my ratio of the leading coefficients. So right now I have an x times an x times an x, so I'd have an x cubed on the top. On the bottom I have an x times an x times an x, so I have an x cubed on the bottom. And right now I have a ratio of 1 to 1. But because the horizontal asymptote is up there at 2, I want the ratio to be 2 to 1, so it has to be 2 somewhere on that top. So I just simply add a factor of 2 on the top. And this is the equation of our rational equation in factored form. There's really no big reason to put that in standard form unless you have a lot of passion for doing that. And I don't care if you do or you don't, so take that upon yourself. Next thing I want to do is I want to make sure we have a graph of this. So what I do know is we have most of our features in place. What I want to do is maybe run a little analysis by this vertical asymptote. So I'm going to pick a number like 4.1 and I'm going to put it into our factored form. And because these are a whole, we can eliminate them in our sign analysis, or you can include them. It's not going to hurt anything. So if I put in a 4.1, this 2 is already positive, so we got a positive there. 4.1 plus 3 will be positive. 4 minus 2 is going to be positive. So all those positives are going to end up being a positive on the top, because positive times positive is positive. On the bottom, 4.1 minus 4, that'll be a positive factor, and a 4.1 plus 5, that'll be a positive. So again, it's positive times positive, positive. And in the end, and positive divided by positive is a positive. So what it's saying is everything to the right side of our graph on this vertical asymptote has to come from positive infinity. It's going to flatten out and then go towards a horizontal asymptote. The only thing I want to include in there is that I got to keep in mind that there was a hole in this graph, and the hole was at 5. So I'm going to go up here where I have that 5, go vertically up there, and it was supposed to be occurring at, let's see, 524, so that should be a little at 5. So what I want to do is come back and maybe readdress my graph, because that hole has to be somewhere at 5. So where that graph is coming down here and then flattening out a little bit more. So if you want to be really technical, it has to be a little bit flatter and shorter than what I have. And then because this had a power of 1 and a power of 1, I know they look like butterflies. So if it was positive infinity on the right side, it's going to come back as a negative infinity on the left side of that vertical asymptote. It has to cross at 2 as an x-intercept. It has to cross again at -3, and then it has to approach the vertical asymptote. So this one's going to negative infinity on the right. which means it's going to return on the left as a positive infinity, flatten out towards the horizontal asymptote for end behavior. So that's the equation I built, and that's also the graph that was created by following our graphing rules.